I think that was a good introduction. I'm not so sure, but anyway, there you go. Yeah, I'm just going to talk to you about our role in modelling, in policy development in human health, and moving on to sort of net zero and how our models can be useful. But first of all, what I wanted to say is what a model is. I want to make sure, because models are used, you know, the term modelling is used all over the place. It could be statistical, could be lots of different things. Our model is basically a emissions dispersion model where you need to look at emissions. We've heard about PM and all the emissions associated with those. It's not only anthropogenic, it's biogenic emissions are really important. Depending on where you're actually modelling, be it a single road or a city or a country, there's obviously contributions, and of course ozone's one of the contributors at hemispheric level, so you need a sort of contribution from the boundary. We've heard about the influence of meteorology, which is really important for concentrations of air pollution. You need to know about the land, the terrain, the contribution from oceans, you know, sea salt, that sort of stuff. As we've heard, chemistry is really complicated and nothing that is as it seems. And of course, the atmosphere itself is oxidizing, so it's a bit like a dustbin lorry. It sort of takes lots of stuff, it oxidizes things and then throws it on the floor. And so all of these are quite important. You need lots of computers to run them, and then you compare with some measurements, you find out whether you're right or wrong, and you know, you start the whole process again. So that's modelling in a nutshell. So the outputs are things like this, and Dave showed this earlier. This is 2018 PM 2.5 annual averages. The colour scheme, it shows you what the concentrations are. So in the UK, it goes from, you know, below 4 micrograms as an annual average, all the way up to sort of 14 plus. And our models have been used quite a lot for exposure work, for health, and also for policy. So I'm going to cover those. We're also, there you go. We're also really interested in trying to get the outdoor exposure right, and obviously we talk a lot about road transport being important, and it still is important, and with the advent of electric vehicles may continue to be important. And so we've done quite a lot of work in trying to improve the spatial capability of our models, and we've done lots of work in trying to get the emissions inventories right, and I have to say we still can't get NO2 right, still under-predicted, even with all the data that's gone before. So we've started looking at inverse modelling, see whether we can use lots and lots of measurements in order to create new emissions inventories and to create the sorts of details that you get in cities and try and determine people's exposure. We've also, we lack transport data fundamentally in our models, and so we've been looking for quite a few years now at deep learning object detection methods using high-resolution satellite imagery to count vehicles, and this is actually Barcelona, and these are the sort of vehicles that we counted along the way. So there's some of these sort of developments that we're undertaking to improve our spatial scale of our modelling. But let's go back a little bit in time to looking at air quality policy. And as has been mentioned before, we've been heavily involved with London air quality policy. And if you see a map a bit like that in a London document, it's basically the models that we've been using in London for a long time. And it's hard, you know, from congestion charging, which is about 2003, right up to the present day ULEZ and the London environment strategy, it's hard to sort of say, you know, this is, you know, what are the lessons learned? But I've tried here. So over that time, we've NOx has actually halved in London from about, you know, 2003 to 2020, mainly from vehicles. So it's not all bad news. There have been some improvements. I think Gary covered the VW scandal quite nicely. So, increasingly, Euro 6 vehicles are actually beginning to perform. Congestion charging is actually, to a certain degree, has been the kind of forgotten method of changing air quality, and it's actually quite a good one because it is really effective at removing vehicles, and it's actually effective at modal change as well, which a lot of people talk about, but it did both of those things, and it has to be designed right from the start in order to do that, and the way they did congestion charging in London was to increase public transport, increase buses and tubes at the time to give people an option. And also a lot of the many times congestion charging was suggested in other cities, and there was always this sort of controversial, all the traffic will move to other areas and they'll become congested instead. But actually in London it didn't really happen to any great degree. So when you're trying to do air pollution policy using technology, there's always problems. It doesn't quite work out the way you expect it to. And we had in London problems with PM exhaust control technology in primary NO2. So we're tackling one pollutant and creating problems elsewhere. The other sort of lessons to learn is there's more to ULEZ or any other policy of low emission zones than the start date. There's an awful lot of work goes on behind the scenes, not least to get the sort of in London's case anyway, the buses and the taxis to comply with the actual rules that you're going to implement. So years and years before you actually introduce the start date of the policy, you have to spend time improving the vehicle fleets, and that in itself is a benefit, I think, throughout London. And I think, as has been said before, there's a non-exhaust issue now. So we've had increasingly good control of exhaust of PM from vehicles, but the non-exhaust is increasing. In our new sort of electric vehicle world, that may increase. We don't know. That only time will tell. But that's the worry, I think. And the final thing is in the London Environment Strategy. It's increasingly part of it is not just about road transport. So it's about boilers, it's about home heating, it's about cooking, domestic wood burning, all those sorts of things, as well as road transport, and also R&MM, which is sort of diggers on construction sites, those sorts of things. So we've built these models. They're increasingly detailed, and so this has been a sort of benefit to the epidemiological community, and we've been involved in quite a lot of the research which is trying to associate air pollution concentrations with health endpoints. And just here, there's a few of our papers, and these are some of the sort of highlights, if you like. So we've been we worked on stroke. Cognitive function is something that we've also worked looking at associations. Psychotic experience in adolescence, that's slightly niche, I guess. Lung function in children, we're still working on that, but we have had papers on that as well with others. Myocardial infarction survivors as well. Fetal growth and the sort of newer area of dementia are all sort of areas that have been studied. And we can use our models not only to sort of try and get the exposure of people in the outdoor environment, but we can also create health impact models, so we can test scenarios, we can change emissions, we can change lots of things within the model, and then do a sort of counterfactual with a new policy, which is the kind of things that we do. And we can increasingly look at health impact assessment. So that epidemiology research goes into the health impact assessment models. And with colleagues, again, at ERG, we've produced a number of recent reports in London on asthma and so on. And here for the Clean Air Fund, we produced a report that was a bit of both. We wanted to look at how we thought PM might change between 2018 and 2030, and also we produced the health impact assessment as well. So we have a combination of those things. But in doing this, in creating these sort of outdoor models and working with the EPI community, we were increasingly sort of struck by the fact that everyone used outdoor air pollution concentrations at your home address effectively. And we thought, well, you can't possibly sit outside your house all the time. For a start, you're mainly inside, apart from this woman. And also you travel around. Obviously, you walk around the city, you go on the bus, you work with Boris Johnson, you go on the tube. There are lots of things you might do in a city that aren't just sitting on the step outside your house. So we wanted to improve the way in which we undertook our sort of modelling work. And so we created this. And again, we have to thank Transport for London for this. So they gave us data, which you might not be able to get again, but I don't know. But it's basically 80,000 people moving throughout the city. So we not only had where they moved from and to, but how they travelled, the time of day, that sort of thing. So you can actually create a sort of model of where people move around. And that sort of coincided with our detailed outdoor air pollution models and how they change. And so people can pick up sort of exposure as they go, if you like. And of course, if they're in the tube, they get quite a large dose of PM, and work by James and David on concentrations of PM in the tube is kind of ongoing. And also in the indoor environment, of course, so when you're at home or in the office, you know, you're not outdoors, and the environment does change, so our model has to sort of cope with that, and we're still working very keenly on this sort of indoor environment to try and characterise people's exposure much more. And this was a piece of work that we did fairly quickly. It was during the COVID pandemic where DEFRA and AQUEG asked for some evidence of the impacts of COVID. And so what we did, we split just in a small area of this model. We chose sort of tube users, children, drivers, which we assume to be sort of delivery drivers predominantly, and hospital staff, and made some assessment of the sort of before and after lockdown, just to give you an idea of how their exposure changed. And also, this is for PM 2.5, we also did NO2 too. And also, because we thought, well, people generally staying at home a little bit more, we did a test to see if we add some more cooking emissions to their exposure, what effect would that have? And it's clearly very important. So that's really spurred us on to sort of do more on building indoor models and coupling that with our detailed outdoor models. So that brings me on to the sort of final sort of section, if you like, and that's on sort of net zero. So, you know, as we've heard before, burning oil is not a great idea for climate, but it's not a great idea for air pollution either. And so if actually you can remove it, then both are going to benefit. And so we have in the past sort of produced work on this going back to 2007 with Paul Wilkinson, and looking at the hydrogen economy, which at the time was very much a sort of a burgeoning idea. It could be the solution that we want towards solving some of these problems. And then it took a little bit of a dip, I think, the hydrogen, but it's coming back again now, I think. We've also done an NIHR project, and with Martin Williams, and we produced sort of air pollution modelling systems, including emissions that were linked to systems energy models, and that's quite important because the whole kind of energy system of an economy is really important and very interlinked, and so that sort of drives some of the emissions that we would want to look at in our model. And that brings us on to the sort of current work that we're doing, which is working with the Climate Change Committee, looking at the impacts of their 6 carbon budget, which is the sort of pathway, if you like, from the UK government needs to take in order to get to net zero. And so we've been looking at 2030, 2040 and 2050. And just to mention really, and this relates to non-exhaust vehicle emissions, which has been mentioned a few times, we pointed this out in this Lancet Countdown, that this is going to be really important for vehicles, and that's the reason why they could continue to be very important. And William Hicks is worth a mention, with Dave. We've done quite a lot of work to quantify using tracers the actual emission factors for non-exhaust emissions from vehicles, and also, I think importantly, the effect of regenerative braking on the change to brake wear emissions, which I think is going to be quite important as well. Okay, so this is some of the results that have come. These are very recent, so we still haven't looked through them entirely, but there's a few take-home messages that we have from our recent NHR work, and this is on average NO2. We've used the balanced net zero pathway, so the Climate Change Committee produced various pathways to get to net zero. The one that's sort of in the middle is the balanced net zero pathway, and we've used that for one of our future forecasts, and it's just associated with vehicles and domestic residences. well, actually no, heating of domestic residences and commercial residences as well. And so what we've done is we've gone from 2019 forecasts in our model to a 2030 forecast using what currently is the government base case, if you like, the things that are already agreed, mainly at European level, and how they envisage changes to all the sources that, you know, in the UK, be it industrial, transport, whatever, at 2030. So that shows there that you get quite a big change, and obviously within cities they tend to be dominant, and also in sort of transport routes and provincial towns. But then if you take the sort of 2030 with the government policy and compare that with a 2030 with the BNZP, so more electric vehicles, for example, there's almost twice as many electric vehicles in that scenario, then you get an additional benefit for NO2. So certainly for that pollutant, it looks quite beneficial. We're going to start producing health impacts and economic costs and benefits, by the way, but like I say, this is an ongoing project. So if we do the same or something similar for PM2.5, you start with your 2019 forecast, you go to 2030 using the DEFRA's base case, and they've been very kind enough to give us some of this data for the future. And you can see even with the base case, you get relatively modest changes not surprisingly, in the north of Scotland, since there's not very much there. And then it moves sort of steadily southeast towards higher reductions according to the forecast, up to sort of 2 micrograms, maybe 2.5 micrograms overall. And then if you look between 2030 and 2040, there isn't much change. It's actually almost stays the same. So there's a competing process between emissions changes and other factors, including sort of changes globally and meteorological changes and so on. But if you implement the BNZP again, and this is really dominated by heating, domestic heating, so removal of wood, changes to gas use, widespread introduction of heat pumps, energy efficiency measures, you can see that there are changes in major cities. That's Manchester, Liverpool, Leeds, Birmingham, and sort of the southeast generally. So there's definitely a benefit for BNZP there. Now, we spent quite a lot of time. It's very complicated, this. I don't want you to look at it too much. Just kind of look at it generally, squint your eyes or something like that. But clearly the changes to emissions are multifaceted. There's behavioural change in the sense that you have to change to improve the energy efficiency of your home. There are things like the low-carbon district heating networks in BNZP. There's installation of heat pumps into houses. Of course, there's new homes as well, which I think was mentioned earlier. And also, I think cooking and the use of gas indoors is really important as well. So that was included. We assume that if you change to a heat pump, you probably get rid of all your gas and switch to electric, for example. So we're going to look at the impacts indoors as well. But I think the main thing to point out is just the size of the numbers. So if you look at the amount of change that has to take place, it's all in the millions of homes, and it gets increasingly large, up to, well, basically all of them, 28 million. That's every house in the UK. So it's really complicated, but the message is really clear. There's a big change has to happen if you're going to hit net zero. And so, you know, this is just one forecast that we've made. There could be any number of forecasts for the future, but the message for all of them will be clear that there is a big change domestically. And so, not to miss out on the behavioural sort of aspects of it, because we're all kind of converging to the same place, it seems to me. You know, how are we going to get people to understand what heat pump is, understand why it's beneficial to them, what health impacts it may have on their sort of lives, what effects it'll have on climate change, why it's necessary, are really big questions now. And so we've started, we're not behavioural people by any means of the stretch of the imagination, but we have started the process as part of this project. We've talked to some children. We thought that they're going to pick up the main issues related to climate change, so it's best to talk to them about it first, to find out what they know, first of all, which when they started out wasn't very much, but actually as we carried on the engagement, they were incredible. They became very knowledgeable and sort of optimistic and cynical at the same time, so it was really quite interesting to see. There are two groups, one in Glasgow, one in London, so very different sort of backgrounds, if you like. And we created a 50-minute film, which isn't as dull as it sounds. It's actually quite entertaining and really was led by the children. I mean, they effectively made it with a filmmaker. And so, I urge you to take a look at that. But, going further and thinking about how we're going to change people's sort of plans and how they're going to meet these net zero challenges, what do we have to do? What sort of messages do we have to give? What does the government have to do? What do scientists have to do? Where's the media responsibility? Policy, fiscal incentives, the whole range of things need to be understood, including sort of co-design and so on. And just to give ourselves a plug, we've got a cohort of, I say we in the sort of broadest sense of the word we, it's Imperial, has a COVID cohort called REACT, which is 3 million people, and it really is ideally suited to sort of answer some of these questions. So that moves neatly into Wouter's talk, because it's not a question I can answer, but I'm hopeful that he can sort of advise on those sorts of things. And so that's it for me. So finally, I'd just like to thank the people who really do all the work, and they include, I think some of them are here. David's here for sure, Gregor, I think Nosha's here as well, Annie's here, I think I've seen Faye. Tuan's just had a child, so congratulations to him, and I suspect he's not really thinking about net zero at the moment. And sort of Philip's here as well. So they're the people who do all the work, and I just talk about it. So that's me.
Thanks, Sean. That was a great overview of not just of what you do for the modeling, but how to then apply it to these, helping to inform these tough decisions. Any questions for Sean at this point? One in the back,
I think. Thanks, Sean. Things have been very dynamic in London. So not only have we got the ultra-low emission zone, but also there's been a lot of traffic calming measures. A lot of streets now, it's 20 miles an hour rather than 30 miles an hour. That will have an effect on exhaust emissions and non-exhaust emissions. And I'm not sure which way it goes. Do you have a view on that? And how do you work out what's actually happening and what's beneficial and what's disbenefit?
Well, I think if we've learnt anything over the years, it's worth trying all of these things. Often people in air pollution want, the sort of silver bullet, if you like, and they want a solution that solves everything. And as we've heard from various people, it's not really going to be the case. So, I don't know that things like low traffic neighbourhoods, although they'd be beneficial sort of very locally to that area, are really targeted on air pollution particularly. So that's for all sorts of other reasons. I think they're a good idea. It's just I don't think you justify it singly on air pollution. I think the sort of 30 to 20 mile an hour limit's going to be beneficial. I think if we can sort of calm vehicles and actually not drive in such an aggressive way, which I think is one of the impacts of 20 mile an hour zones, would be very beneficial too. Of course, with other things as well. Actually, it's quite a difficult thing to assess. I don't think necessarily the modelling tools that we use are all that suited to that sort of thing. So, you'd probably do quite a small study rather than some of these big studies. But I think my comment overall is all of these things have good intentions and are justifiable for all sorts of reasons and probably will be beneficial to air pollution. So yeah, I'm a supporter basically. Mm.
Yeah. Yes, right here.
Hi there. You talked earlier about some of the challenges modelers face being the chemistry element of it. To what degree are your modelling team looking at using AI to answer some of the problems that humans are struggling to actually calculate?
I mean, early on we started using deep learning object detection, and we've also started looking at inverse modelling to try and kind of resolve some of the problems that we've had with emissions inventories. Because some of the biggest sort of bang for your buck, if you like, in terms of modelling, is getting the emissions right. And we've been trying for ages, and we're still struggling with some of it. And so I think we can use machine learning and AI in that sense. And also with our indoor modelling as well, we've found that there's a lot of heterogeneity in the sort of indoor environments. And so I think we can use machine learning there as well. But we have to be a little bit careful the way we use it, because if you just get your model and use AI and then get a great answer, then you can't really forecast forward. So you've got to be quite selective. So what we've tried to do is use it on things that we would then feed into the model and keep the model as a kind of just pure emissions dispersion, CTM type application. So that's the way we go.
That's it. Please.
Hi, Sean.
Hi.
I'm wondering whether part of your modelling has been taken out of context by the general public, because they see graphs of things dropping, things going down, and they believe, I mean, this is the first time I've seen some orange and dark red. All I see being thrown at me on Twitter is bright blue and green, i.e. air pollution is not a problem. And I'm wondering regarding messages, whether one needs to be very, very careful when it comes to the public and what they are receiving, because they do not believe air pollution is still a problem.
No, and I think some of that is the sort of air pollution sort of now. I think people are using sort of what's air pollution like today, and they sort of say, it might, on the 1 to 10 scale, it might be okay today, and that's probably mainly due to meteorology. If the wind's blowing, if it's raining, it's going to be okay, compared with the sorts of things that we produce, which is kind of annual averages. And to people, air pollution's air pollution. So it's not, it's contradictory, but in reality, it's not contradictory. And so I think we have to be really careful the sort of source of this data to say whether air pollution's bad. So I think we could do more by sort of producing these maps and then comparing with the new WHO standards and just sort of trying to be fairly clear. This is what it means. This is what the current state is, and that, air pollution still is a problem. And just because it isn't, particularly high today, doesn't absolve you of any responsibility for it going forward. I think that's probably the main thing.
Sean, I say for the LEI for London, we did actually review those the colours on there in relation to the WHO limits, because obviously the changing narrative of even the understanding of what levels are important for health, obviously challenges around government levels versus WHO. So the new maps for the LEI, and those have been updated for the historical ones as well, right, to reflect that better. Again, it's difficult because it's about the time when you do that, because we have to try not to confuse the public. Yeah. We're obviously trying to make a positive message about the changes that we're making to air quality. Yes. And obviously that's a challenge in itself, because you almost feel like we know we've got more to do, but we're almost like a victim of our own success because we have actually finally delivered something. Yeah. But yeah, that's a really important part on the colours. And again, that's something that we've done recently.
Yeah. Okay. Oh, good. Yeah.
These are good points, and I think we're just about wrapped here, but I just want to say that earlier today, I think it was Gary who put some counterfactuals up, and you wonder in terms of, you want to present models that say, well, if this policy is implemented, that it will have these benefits, but if the result is that the maps are all nice and green, and we don't know if those policies will actually get implemented, and all the behavioral things, which we're about to get into it more, then you almost want to have the counterfactual map as, this is what the map will look like if we don't succeed. Yeah. But that's a negative message, so it's a little tricky to figure out how do you do that. But it's important, important communication. Thank you very much. That was great.